Welcome to Agial International Language Schools. Let's start our first lesson in Unit 1. But before starting, we will talk about something we studied in primary force called matter. We said that matter, it is everything we see around us that has a mass and volume. For example, table is a matter, the water is a matter, and the gas is a matter. We said that the table is a matter because it has a mass, as when we try to carry it, the table may be light or maybe heavy. And we said that it is a matter because it has volume too. The volume is the space which the table occupies. So we can say that the table is a matter because it has a mass and a volume. By the same way, the water is a matter because it has a mass and a volume. So we can say the water and the table are matters because they have mass and volume. The next one, the gas is a matter because it has mass and volume. Based on that, all matter, whatever their physical state, which is solid like table, and liquid like water, and gases like the air, have mass and volume. In this lesson, we will talk about something called mass. What is the meaning of mass? Mass, it is the amount of matter in an object. Let's see an example. A cup of water. It consists of many drops of water. So we can say that the mass of the cup of water is the amount of drops of water in the cup of water. Let's see another one. A golden ring. It consists of many small parts of gold. So we can say the mass of the golden ring, it is the amount of gold in the golden ring. So the mass, it is the amount of matter in an object. We use many types of scale to measure mass. The scale maybe has 2 arms or it maybe has 1 arm. 2 arms like balance scale, which we can use to measure the large masses like vegetables and fruits, and sensitive scale, which we can use to measure small masses. And the other type, the scale which has 1 arm like 1 arm digital scale and 1 arm scale with pointer. So there are 2 types of scale. The first one is the scales which have 2 arms like balance scale and sensitive scale. And the other type is the scales which have 1 arm like 1 arm digital scale and 1 arm scale with pointer. Now we will see how can we use each one. If we want to measure an amount of apple by using a scale which has 1 arm, like 1 arm scale with pointer, before measuring we should make sure that the scale is putting horizontally. Horizontally means putting in one line to avoid any vibration to the scale. Then we will put the object that we want to measure its mass on the scale. The pointer will point to the apple's mass, which equal 2 kilograms. We will use another one. We will use the 1 arm digital scale. Also, before measuring, we should make sure that the balance is putting in one line to avoid any vibration to the scale. Then we will put the object that we want to measure its mass on the scale. Then the apple's mass will appear on the screen, which equal 2 kilograms. Now we will use another scale, which is balance scale, which has 2 arms. Before measuring 2, we should make sure that the balance scale is putting horizontally or in one line. Why? To avoid any vibration. Then we will put the object that we want to measure its mass on one of the 2 arms. We will see that the mass of the arm that includes the apple is bigger than the other arm, and we can't know the apple's mass. To know its mass, we will use another thing to put in the other hand, which is called standard masses. Standard masses, which is the object we know its mass. We will put standard mass, which its mass equal 1 kilogram, and we will see what's happened. The mass of the arm that includes the apple is bigger than the mass of the other arm that includes the standard mass. That means that the mass's apple is bigger than 1 kilogram. Then we will use another one. We will put a standard mass which mass equal 2 kilogram and see what will happen. The mass of the arm that includes the apples equal to the mass of the other arm which includes the standard mass. So the mass of the apple is equal to 2 kilogram. So when we put the unknown masses on the first arm and the other has a standard mass, the mass of the other arm that includes unknown mass, which is apple, should be equal to the mass of the other arm that has a standard mass. So, based on that, we can know the mass of the apple, which equal to the mass of the standard mass, which equal to kilogram in this case. So, the mass of any solid object is equal to the total mass of the standard masses which balance with the object. On the same way, we can measure the mass of a golden ring, but instead of using the common balance and its standard masses, we will use the sensitive balance or sensitive scale and using its standard masses, as the ring is a small object. As we saw, after measuring apples, we said that its mass equal 2 kilogram, and it also equal 2,000 gram. So the measuring units of mass are gram and kilogram. Gram, which is a suitable unit for small objects, and kilogram, which is a suitable unit for large objects like vegetables and fruits. So 1 kilogram is equal 1,000 gram. Let's see how. If I have two objects, one of them is an example of a large object like distilled water, and we have another object which is a small object like paper clip. We will measure the mass of the distilled water and we find it equal 1 kilogram. Then we will measure the mass of the paper clip and we will find it equal 1 gram. Now, as we see, the mass of distilled water is bigger than the mass of paper clip. Now, I want to let the mass of distilled water is equal to the mass of the paper clip. So, I have to put 1,000 paper clips to make the balance. So, the mass of an object that equal 1 kilogram is equal to the mass of an object that equal 1,000 gram. Till now we talked about something is called matter and said that it is everything we see around us that has a mass and a volume. And we talked about mass and say it is the amount of matter in an object, and we talked about the mass measuring tools like scales have two arms like balance scale and sensitive scale, and their scales have one arm like one arm digital scale and one arm scale with pointer. And we talked about the measuring units of mass, which are gram and kilogram, and we said that 1 kilogram is equal to 1,000 gram. Now we will talk about the properties of mass. The first one, all matter, whatever their physical state, which is solid or liquid or gases, have mass and volume. The second one, the mass depends on the amount of matter. For example, if I have 3 one-arm digital scales, then I will put in the first one an empty cup of water, and I will see its mass, which equal 1 kilogram. Then I will put another cup in the second scale, which I fill its half with water, and I will see its mass will equal 2 kilogram. Then I will put the third cup of water and its mass will equal 3 kilograms. So when I increase the amount of water, the masses increase. So the mass of an object increases when the amount of matter in it increases. And if I decrease the amount of water, the mass will decrease. The third property is the mass of any object doesn't change by changing the place of matter. For example, as we know that we live in the Earth planet, and we measure the mass of the apple, which equal 2 kilograms. Now I will take the apple to Jupiter planet, and I will measure its mass. It will be equal to 2 kilograms. Till now, we finished the first part in our lesson. Let's see the next part. The next part we will talk about something is called weight. But before talking about weight, let's say a story. Once upon a time, there is someone called Newton. He stood under a tree. Then he found an apple falling down to the ground. And he wondered, why did the apple fall down and didn't fall up? By the same way, we can wonder too, why does it hard to take something from the ground, but it is easy to fall it down? All these questions, Newton answered it. As he searched for the reason for falling the apple down, then he proved that all masses or matters on the Earth's ground are attracted to the Earth by a force found on the center of the Earth, which called gravitational force. One more time, gravitational force. For the last time, gravitational force. Or we can call it weight. One more time, weight. The last time, weight. So the force is called gravitational force or weight. Because of the weight, we don't fly in the air and stand on the ground, as the body is attracted to the earth by the weight force. But if there is a big distance between the body and the center of the earth, this force will decrease and become weak, and that is why we can see astronaut flies on the space. So we can say weight, it is the force by which a body is attracted to the earth. Or we can call it, it is the gravitational force by which a body is attracted to the earth. As we said in the mass, we using a measuring tools to measure the mass of an object. By the same way, the weight has a measure tool to measure the weight of an object. This tool is called spring scale. One more time, spring scale. The last time, spring scale, which consists of 3 parts. The first part is the top hook to hold the scale. The next part is bottom hook to hang the object up the scale. The third part, a spring with a pointer. Let's see an example. We have 3 standard masses. The mass of the first one is equal 1 kilogram. The mass of the second one equal 3 kilogram. The mass of the third one equal 5 kilogram. Let's see how can we know its weight. We will put the first object up the scale. We will see its weight will equal 10. The next one, its weight will equal 30. The third one, its weight will equal 50. Based on that, we can conclude the object's weight equal its mass by 10. The 10 is the acceleration of the Earth's gravity. Let's see an example. The mass of a person is equal to 70 kilogram. Calculate its weight on the Earth's surface. We said the object's weight equal its mass by 10, which equal 70 by 10, which equal 700. We said the measuring unit of weight is Newton and belongs to Newton, the hero of our story. Definition of the Newton is the measuring unit of weight, which is almost equal to the weight of an object on the Earth's surface, whose mass is 100 grams. Let's see how. Newton, we will say it is equal 1. And we say it is the measuring unit of the weight, which equal to the weight of an object, like the apple object, which found in the surface of the Earth. The mass of the apple object will equal 0.1 kilogram, which equal 100 gram. So we can see the weight of the apple equal its mass times 10, which equal 0.1 times 10 equal 1 Newton. So the Newton is the measuring unit of weight, which equal the weight of an object on the Earth's surface whose mass is 100 grams or equal 0.1 kilogram. So 1 Newton equal the weight of an object on the Earth's surface, which is apple, which is mass is 100 grams or 0.1 kilogram. We said before the mass of any object doesn't change by changing the place of a matter, but the weight is not, as the weight of an object differs according to the planet or the moon where the object exists. Let's see an example. The weight of an object on Jupiter is different from the weight of an object on the Earth. Why? As the mass of the Jupiter planet is bigger than the mass of the Earth planet. So the gravitational force, which is responsible for attracted object on Jupiter, is bigger than that on the Earth. Or we can say the weight which is responsible for attracted object on Jupiter is bigger than the weight which attracted object on the Earth. By the same way, the mass of the Earth planet is bigger than the mass of the Moon. So the gravitational force or weight which is responsible for attracted object on the Earth is bigger than that on the Moon. Based on that, we can say the weight of the object on the Moon's surface equals 1/6 of its weight on the Earth's surface. Why? As the Earth has mass greater than the Moon. Let's see an example. The mass of a person is equal to 70 kilograms. Calculate its weight on the Earth's surface and its weight on the Moon's surface. Firstly, we will see the object's weight on the Earth. It will equal its mass by 10, equal 70 by 10, which equal 700 Newton. The object's weight on the Moon, its weight on the Earth, time 1/6, which equal 700 by 1/6, which equal 116 Newton. Why we say the weight of object on the Moon is equal the weight on the Earth time 1/6. Let's see why. This part doesn't found in your book. It is just for knowing. Again, this part doesn't found in your book. It's just for knowing. The acceleration of the Earth's gravity, we said that it's equal 10. And it is bigger than the acceleration of the Moon gravity, which equal 1.6. Why? As the mass of the Earth is bigger than the mass of the Moon. So, as the object weight equal the mass time the acceleration gravity, So the weight of the Earth will be bigger than the weight of the Moon. Let's see that. In the last example, the mass of a person is equal to 70 kilograms, and we will calculate the weight on the Earth's surface and its weight on the Moon's surface. On the Moon, we say it's the object weight. In any place, it's equal mass time the acceleration gravity. In this case, the weight we have 70 kilograms times the acceleration gravity on the Moon, which equal 1.6, and it will equal 116 Newton. In case of the object's weight on the Earth, it will equal the mass times the acceleration gravity, which equal, we have the mass, which equals 70, times the acceleration gravity of the Earth, which equal 10. And it will be equal 700 Newton. Now, I want to try to divide the weight on the Moon by the weight on the Earth. I would have 116 over 700, which equal 1 over 6. So we can get the weight of an object on the Moon by only one step, which equal the weight on the Earth times 1 over 6. So we can say in this case the weight of the object on the Moon equal its weight on the Earth times 1 over 6, which equal 700 times 1 over 6, and it will equal 116 Newton. It's equal to the weight of the Moon by using its acceleration gravity. So we can get the weight on the Moon, or we can get the weight of an object on the Moon by only one step. Till now we talked about the weight, and we said that it is the force by which the body is attracted to the Earth, and the measuring tools of weight like spring scale, and the measuring unit of weight, which is Newton. It is the measuring unit of weight which almost equal to the weight of an object on the Earth's surface, whose mass is 100 grams. So we will talk about the factors affecting weight, like the object's mass, as when the masses increase, the weight will increase, and if the masses decrease, the weight will decrease. The planet where the object exists, and the planet maybe has a big mass, so it will have a big weight. It maybe has a small mass, so based on that it will has a small weight. The distance between the object and the center of the planet, as if there is a big distance between the body and the center of the Earth, the weight become weak.